Hi and welcome to a new video on my channel. First of all, thank you for your comments and for your positive support. I read through all the comments, hopefully I answered all the questions. And as stated in the last video, I try now to give you a short introduction into barcode and QR code reading in Unity, and in this project or in this video we'll take care of all possible forms of barcode and QR code reading, covering all the platforms, going from Android to Standalone, WebGL, and the UVP platform, especially HoloLens. I won't do the iOS thing because I don't have an iPhone and a Mac here, but it should be basically work the same way as on Android. So for creating the QR codes and the barcodes, I'll just use the QR code generator. Feel free to use whatever generator you want. Download the JPEG and use it for your webcam. Same goes for the barcode. I'll just googled the generators. Basically all the generators should work the same. We will explore a way to generate codes ourselves here as well. So we'll be able to cover the full spectrum, and for this tutorial we will start with our standalone sample and use the zebracrossing.net implementation from Mikion, which is basically the way to go when it comes to barcode and QR code reading in Unity or .NET related applications. There are plenty of projects in the Unity asset store as well, but I decided to go with zebra crossing here. You can download here from the releases section because it's the easiest approach and with a little bit of optimization. Also the most basic way to deal. In the downloaded zip there is a DLL in the Unity folder, zebra crossing Unity DLL. I'll just put it into a plugins folder in Unity. You will be able to get everything from the Github repository. The link is in the description, and we will support every platform with just this library. So I'm going back to the main page. There is also scrolling down a little code sample where we can create the barcode reader, do something with an image that we might get from the hard drive or for the webcam, from the webcam, and decode the result into some kind of text, barcode format, and lots of additional information. And I created samples in various ways and even provided a texture 2D because everyone wants maybe to work with it, so you don't have to deal with it yourself. And we'll just start with a very easy reader sample. We'll provide the string result from the red barcode. We capture the webcam texture from our webcam, save the data in a color 32 array, save some data for the screen rect, and create the barcode reader with zebra crossing as it's stated here in the source code example. There are a lot of options: auto-rotate and try harder. You can feel free to set them to true if you have any troubles reading the codes. I set them to false because it's better for the performance and storing the result in a special result class from zebra crossing. We're going to set up the webcam texture. This process will be very similar to nearly each implementation we'll be talking about, and then we'll play the webcam texture. Feel free to consult the Unity docs if you're not sure what we're doing here, because it's pretty basic stuff. It's just creating the texture, playing, and getting the image data from it. In the start method and in the onEnable method, we'll try to play the webcam texture. On disable we pause it, so even when we're pausing the application this should work. The last result is just set to something, and the camera color data array will hold all the color data from our webcam texture. So it's basically width multiplied with height. For every pixel there will be a color 32 struct, and the screen rect is just for displaying everything on the screen. I'll go with the default onGUI method here. Speaking of the webcam texture, it's a Unity class which gets the texture from the webcam automatically, so we don't have to think about everything else, and the method getPixels32 will just save all the texture data in our array. Please note that there is a parameter for this array, and the Unity documentation states that this way of calling getPixels will avoid allocating new memory each frame and will improve our performance. Not by much, but well, every pixel counts, and if Unity docs says it should be true, I measured it myself, but it's not that hard, especially on standalone platforms. On mobile platforms, everything looks a little bit different. So we're getting the pixel data every frame in the update method, and following the retrieve sequence, yes, okay, sure. And the barcode reader will decode this data, will look for barcodes and QR codes within there and store it in a result class. This is also a performance-heavy method. We'll see it here, the reader.decode. We can also decode multiple codes in one picture, but we won't cover it here. Feel free to consult the docs here. And if the result is not null, we'll display it in our string variable, print it in the console, and last but not least, we'll draw all our stuff like the texture and the result on the screen. Here too, feel free to use a more advanced UI method like the Unity GUI. Stop it on destroy, and all that's left is now playing it in the editor and check if our webcam is working. Here we go. The webcam picture is displayed. I'll just grab the first code, hold it into the camera, make sure the lighting is good, and we'll see here that the QR code is read successfully. We have a message even in the console. Now I get the barcode up, and it's also nearly read instantly. So looking at this simple example, everything now already works. But as I mentioned before, these methods we're using, the getPixels and the decode method, are pretty heavy when it comes to the performance. We'll deal with that later on. Now we'll have a look at the writers example. It's built up pretty similar to the reader, so we're now trying to write a QR code to the screen to generate a texture which also contains a QR code. So we'll just create a texture 2D here with a fixed size, the color data array. We create a new barcode writer, tell the barcode format that's a QR code, and the enum basically has more ways to generate code, like code 128 and QR code. We'll give it a height and a width, and in our update call we'll just write our result data. In this case it's a Google link, set the pixels of the texture, apply it, and then display it on the screen. You can also make the texture bigger, so I'll just stayed with the 256 for, well, it looks pretty okay in the editor. Let's see, we've already activated the writer sample, click on play, and as you can see there is a QR code generated here and displayed on the screen. You can also read it. It's not that sharp at the moment, but feel free to make it bigger to make it sharper. So moving on to the next sample, I'll call this easy sample, and this is basically just a merge of what we've done now. So combining the reader and the writer here, so just putting it together. I won't go over it from full start, just to give you a short impression here. Everything is still located in the updated method, and the code is also provided in the GitHub repository. Feel free to check it out in the description box. As we can see here, barcode reader, barcode writer, the result, initializing our WebcamTexture the same way we did before. And on destroy we stop it, on enable we'll play it, on disable we pause it. It's the same, we generate the camera color data where our pixel data will be stored in. we have our writer here, which will display a QR code on the screen, reading the data from the webcam, decode it, print the result, and the same for the writer, write with the last read result a new barcode. So we'll just start the application here. I'll display the frames here to show you that this implementation is not the most effective one. And we'll see that it's basically running with about 30 frames. There's a barcode created. I hold the barcode into the camera and we see that the barcode is read, but it looks differently from the one generated. This is absolutely normal. So barcodes can look differently but contain the same information. And the same goes for the barcode with the numbers, and there is a QR code generated for this. So despite the massive frame drop here, everything works good. And we'll now tackle the frame drop with our next implementation. This implementation will combine the reader and the writer, but every performance-heavy method, except the Unity methods, will be moved to a separate thread. Let's check the clients folder. There is the Unity demo, assets, scripts, and there is the barcode cam script. And all that's included here is basically this script, which will work in a separate thread. All the work that's done in a separate thread is just the barcode decoding that may be, or is actually, a very performance-heavy method. Please note that Unity methods cannot be executed in a separate thread. Unity will also throw an exception here. I'll just walk shortly through the code. Everything is more or less the same as we did before. There is a GUI method for the draw texture, for the code, for our result, and for our webcam. The webcam is paused and played here. On this thread, the thread is aborted and the CamTexture is stopped. We set the isQuit flag for the thread. Everything is the same here. We're creating a texture, checking for encoding, the screen rect for displaying it on the screen, the CamTexture we call on enable here for playing. I moved it to a separate method, and after defining our color array, which is called C here, we're starting the decoding thread for decoding current texture and check for barcodes or QR codes. Here we go. We're creating a reader here, and while this is true, we'll check if we should quit now or if we should decode the current camera image. And if we found something, the result is displayed on the screen. Note that there is a thread sleep method. This will be visible in frame jumps. So every time we finished reading, we will encode our barcode or QR code in a new QR code and display it on the screen. And after this happened, we'll activate the thread here again and wait for the next reading, code reading. Let's call it code reading. Exactly here, and we'll again create a texture 2D for everything else. And here is our encode method, which just creates a barcode writer and writes everything for creating the new QR code. And let's start the application and have a closer look at the frames. And as you see now, the frames already are at about 200-300 frames, and they will more or less stay at this level. The frame drop is quite high, reading the barcode here and creating the QR code there, and the same goes for the QR code. And as you see, the frame drops are more or less around 250 and 320 frames, so about 70 frames of frame drops. The base example here is okay. I would say it's okay, but you can do some reworking here, make it a little bit more efficient, especially moving the encoding stuff to a separate thread too. And I just included that for you. So I have a reworked sample here, which is a little bit more cleaned up. The variables are named. It's basically coded more or less the same way as we did before. WebcamTexture, the screen rect, the color data, etc., etc., and a cancellation token source for canceling our two threads, where one thread will do the encoding and one thread will do the decoding, and they will wait for each other. So if the encoding thread has something, the decoding thread will take over, and the other way around. And again here, setup and play is basically the same. We'll make everything ready for our screen display here again. Encoding are in a separate texture, creating the writer, and in our thread pool we'll queue our two methods. The first one is the get code from image data, so we'll decode our webcam image with a cancellation token, which will check if the cancellation is requested. If that's not the case, try to decode, and if you found something, start encoding this information into a new barcode. And the same goes for the second thread, encode new from last result. Do the encoding as long as the cancellation is not requested, and generate the texture for displaying it on the screen. And in the update method, we'll just check if we should now decode or encode, and we'll additionally check if there is some color data created and provide the texture 2D. And we only have two performance heavy methods here, the get and the set pixels 32, and everything else is moved into threads. So this should run way more stable than this one here, because we don't use the thread sleep. The overall performance will not be that high. The peak of the standalone base sample will be higher, but this should run more stable. And well, yes, the on-GUI method is basically the same as before. In the onDestroy method, we'll just cancel our cancellation token, stop the CamTexture, and dispose the cancellation token, so we will not get any errors from Unity here. And let's check. The object is already active, nice, and we'll click on play. And we'll see that the frame rate is somewhere around 250 to 270, and it will basically not drop under 200 frames, so it runs stable. And we see here one of the disadvantages: our camera image decoded a different barcode because the image wasn't sharp enough. And well, it's not good, but it's also not bad, but it works, and it works in a very stable way that should even enable applications to run for a longer time. So that was for standalone. I'll just prove you that this will also work after building. So we'll just going to build the standalone build. Please note that these builds are not included in the GitHub repository, so you will have to build them yourself. And you see that even the Unity version with 2021.3.7 is pretty the latest version. So starting after build succeeded, the standalone solution. Here we go. The webcam is started. Here is the barcode, works. Here is the QR code, works. And well, everything works. let's move on to the next platform. I guess seeing the Android sample is way better for most of you, because reading codes with a mobile platform is the common way to do it. We just switch here. There's a different scene for the Android stuff here, and we'll not just stick to the default implementation here, because just a short pause here after I switched off all the stuff we won't need for the first try. So the implementation of the standalone sample basically works on every platform. Basically, there are limitations, so limitations apply, but it basically works. But performance-wise, it's not the best to use the update loop for every for querying the image every frame, and especially not on mobile platforms, because when this will be done every frame, the application may signal the operating system of your mobile phone, either Android or iOS, that it's going to overheat, because the CPU will have to work quite a bit, and this may lead to an application crash, basically. So we'll talk about that in a minute, but this version for mobile phones will work with ARFoundation, and we'll use specific methods from that. Everyone who followed the AR indoor navigation tutorial is already familiar with the AR image querying for code reading, but I'll walk you through that in a second. Here we go. So first of all, we're using the ARFoundation methods here, and using the AR session origin, and our AR camera manager. And there is, for accessing the device camera image on the CPU, there is also documentation. The links and everything else is in the description box. And we can acquire, I'll make it a little bit bigger for you, the CPU image for OCR applications. Whatever kind of computer vision algorithm you want to apply, it's absolutely possible. You can either use these planes here. There is an asynchronous example, but we'll just go with the basic sample, which can be found here, which will have its own camera frame received method, and after all the default code after the buffer dispose will apply our own code. We cannot use the convert async here, because we need our image immediately. We want to have the feedback as soon as possible, but also feel free to dive a little bit into that. There is also example code on here, which can be used for async image processing. Just as a short note, the XRCPUImage API is not implemented for HoloLens yet. The HoloLens support is already here with version 5 of ARFoundation, and I'm pretty sure that it's just a matter of time that the XRCPUImage API will be also available on the HoloLens platform. But for now, we'll just cope with it, and we'll work ourselves through our example. As said before, this is all the default code. We just have the last result here and the barcode reader and our result class for working on this. We have our camera manager frame received methods. We'll just register here, and we try to acquire the latest CPU image as it's stated in the example code. I didn't change it here, so just copy it and you can use it. And here is where the magic happens. We're just using our barcode reader decode method to get our pixels as we did before, and decode our image and look if we found something which will result in a text or a barcode format. Again, it will be displayed with our onGUI method. Again, feel free to use a more advanced way of displaying it. When pressing play, we can't see anything in our game window, but our application is now so light, so it doesn't matter at all. we get the usual Unity XR subsystem errors. Just going to build settings. If a device is attached, you can just click build and run. I'll just click build my APK and manually copying it to my smartphone. Give it a few seconds for building. Yes, the build succeeded. No problem at all. As the performance is not that good, we'll just skip this test. You can always move the decode method into a separate thread here again to gain additional performance. I'll not do that here, and I called it ARFoundation version below. That's not quite true, but we'll just use now some more advanced UI techniques here. And we have another script which is called toggleable, and is basically the same script, just with additional option. We're displaying our text and we're checking if the scanning is enabled. As I said before, it's very important on mobile platforms to toggle on and off the scanning. There is the state message in order to save performance and to make it more efficient and to keep the application running. We just have our debug text here. I'm pretty sure that's nothing new for you, and we'll just trigger this state text query either on start or with the toggleable button in the center of the screen, so we can just toggle our scanner on and off. It's just a screen space overlay canvas with a button and our result text. Here is the button, and in our onClick method there is the Android code reader toggleable, toggle scanning, and even again on the Android code reader object, the show scanner state set code reader state text method linked. This is our text mesh pro text for the scanner state, and the other one is the last result text, where we just can display everything to make it a little easier for us to check for the results. So in this video we see our application working. Here is the QR code, it's red. Here is the barcode, it's red too. So it basically works without limitations. So I guess it's time to move on to the next platform, which is WebGL. We won't change anything when it comes to the default settings. Just click on switch platform. Let the player rebuild. Waiting for the rebuild, and open the WebGL scene. And as you can see, there is only one object here, which is called the WebGL Easy Reader Sample. And when we open it, just closing all the other scripts, the WebGL in Unity can basically access the webcam. There is a very good code sample in the documentation, and the user has to provide permission. I also tried this after publishing our WebGL build on a currently running web server, but we won't need to do that because there is also a way to do it locally, and we just have to request our user authorization. Unity recommends a different method, but I'll stick to the default code because this will require HTTPS, and with the local development we only have HTTP, so just for testing reasons we'll stay with the default code, with the demo code, and it's basically again the same as we already did. We have the WebcamTexture, we have our color data, we have our barcode reader. We can set up and play the WebcamTexture after getting the user authorization for accessing the webcam. We'll create a new WebcamTexture without any parameters. On enable we'll play it, on disable we'll pause it, on destroy we'll stop it. Well, here we go. Here's the update method. There's just one thing to mention when it comes to the browser-based solution. It will take some time for the WebGL build to recognize that our cam is actually working, and it will just return a cam texture width with 16 pixels each side at the beginning, and we'll just wait for it. And after the final webcam setup from the browser is completed, we'll generate our camera color data, our screen rect, and get ready for reading barcode data here, getting the pixels decoded and printed on the screen. Again, feel free to move the decode in a separate thread. There is no reason to keep it in the update method. I'll just try to keep it simple here and not apply threading all the time. When it comes to the WebGL build, you can just click build and run, and Unity will spin up a local development server for you. Many people don't know that, so I'll just show it. Select the folder, let it build. This build can take quite some time, as you see here, about 2 or 3 minutes, I guess. Well, it's even longer. But our localhost is now spun up. We can even open the developer console. We'll allow the access for a webcam. There is a webcam. I'll open the developer console in Firefox. We can check our logs here, and as soon as the browser window gets our focus, we'll see here, okay, the code is found, it's read every frame, and even the QR code is working. Here we go. And as you see, the WebGL build, it's easy as that. Getting it up and running, I mean, at least if you know how it's done. Even in the editor, we can just click on play. Wait a second, and here it is. So even in the editor, we can just play it, and the webcam scan for the code does work, and it's actually going pretty well. After finishing all our basic stuff, we'll just move on to a little advanced topic, the HoloLens build or UVP build. Again, the default implementation for reading and scanning barcodes, QR codes from the standalone sample can also be used here, but the HoloLens is very sensitive and a very, I would say, not the strongest hardware for computer vision in the moment. And I'll create a very simple sample for you. I'll just activate it, HoloLens Easy Reader Sample, and we're checking the code here. This is the default method that I mentioned before, without the threading. With threading you can get decent performance, but it's not that perfect anyways. And I'm using a HoloLens 2 here. If you might ask yourself what kind of HoloLens I'm using, well, it's the same setup: play, stop, pause, etc., etc. I'll just click play here in the editor, and as you will see, there is no camera image, but the webcam is actually working. So if I pick up the code, hold it into the webcam, give me a second, here it is, the QR code, and if I hold up the barcode, come on, here it is. So you can basically test it in the editor without always having to deploy it to your HoloLens. That's a very nice approach, and you see that I'm not using the MRTK from Microsoft here. I'm just going with the OpenXR implementation. We'll talk about it in a second. I'll just create the build here. HoloLens build. Yes, here we go. And I'll show it up and running on the device. HoloLens build, open the solution here. Everyone who's already developing for HoloLens knows the struggle and all the waiting for final deploying all the settings here. Click on Start without debugging. You can also build, rebuild, deploy the solution as you wish, so there are many ways to achieve your goal. I'll speed up the video here. And here we go. You can see it here in the video now, but it's actually running on, I guess, 2 frames, and it's still working. So this may look cool, but remember, these are just 2 or 3 frames, so we'll omit that. You can, again, apply threading here, get more frames out of it, but it will never run perfectly. So we're switching now to the OpenXR implementation, and the Windows XR plugin Microsoft recommends using the Unity OpenXR plugin, and for installing it into your project you will need the Microsoft Mixed Reality feature tool. Everyone who already Googled it will have stumbled upon it. There are some requirements like having that .NET 5 and Windows 10, getting started here, selecting the project folder and install only the OpenXR package. Everyone can also do it with MRTK, but I decided for the sake of this tutorial to do it without MRTK, as it will stay a lot easier here. So I basically followed this tutorial. The link is also in the description. Set everything up. Here are the project settings again. They're the same. They may look slightly different, but that's not a problem. Okay, here again, download the Mixed Reality feature tool, select your project, and under platform support only install the Microsoft Mixed Reality OpenXR plugin, and in our XR plugin management, in the management itself for Standalone and UVP, just select OpenXR and the Windows Mixed Reality feature group. There will be a few things to fix, but this tutorial keeps you covered and helps you by dealing with all stuff of setup here. I will not recreate it here, so just feel free to follow the tutorial here on the Microsoft page. Again, the link is in the description box. Apply the settings for all the components. Again, we're just checking it here. The other settings, .NET Framework, IL2CPP, everything is ticked. In the publishing settings, make sure that Internet Client Service, the webcam, the microphone and the spatial perception, as well as the gaze input, is enabled. This should do. Again, yes, that's it. And then the XR plugin management, HoloLens feature group, Windows Mixed Reality feature group. Here we go. I just, again, followed the tutorial. The only thing that I have different is the depth with 24-bit, but well, that's not a difference for the build. I just followed the sample implementation, and now is the tricky thing. There is a Microsoft supported QR code tracking in Unity. Here is also everything you can learn about QR codes and QR code tracking. Please note that this only supports QR codes and not barcodes. So it's also called the QR code sample. But this sample link has one drawback. It's supporting the QR code reading with the help of MRTK. So although everything is the same with or without MRTK, this specific GitHub repository only supports MRTK and the Mixed Reality plugin from Microsoft, and we have to use the NuGet package for this. And to get this package you have to use the NuGet for Unity. Again, the setup is not that simple here, so we'll just get Unity NuGet for Unity, import the Unity package. Everything is already in the project if you download it from the GitHub repository. And when clicking on NuGet and manage NuGet packages, we can just enter in the search field the mixed reality Microsoft or Microsoft QRs. It's even better. Click on search, and we see that the Microsoft Mixed Reality .qr package is already installed. I click on the installed tab here, and it's already in there. Without this, this won't work, so make sure that this is installed, up and running. And well, yeah, the Mixed Reality tab for apply the settings here. On the main camera there is also already the track post driver. This will look different with the new versions, but will be basically the same. The next thing is a directional light and our reader sample, which is based on this QR code sample, but if you scroll down a little bit wider, there is this OpenXR sample. And again, it's stated here, it works with the WinRT APIs in the old versions and the Windows XR plugin. And there is a difference in the spatial graph node when only using the OpenXR implementation. And there is also the link for the OpenXR repo. Here we go. It's, as you see, the same thing. You can download it, you can just walk through it. I just copied basically the code here and applied a few changes to make the project still buildable for multiple platforms. And when we dive into it, in the scripts folder there are just a few scripts which should be copied, and the assembly definition file, yes, sure, and everything else is basically the same. The very differences in the node tracker, which will use either the mixed reality OpenXR spatial graph node or the own spatial graph node implementation from the project. Here we go, and it's actually trying to track the code, and these are the two different methods here, one for OpenXR and one for the, I would say, the normal HoloLens built with MRTK. And all of the other code will stay the same. So let's look into it a little bit more. There's also a second repo called QR tracking, where all these changes are applied, but it's more or less a duplicate, so we can just delete it. Here is the link for the NuGet package, Microsoft Mixed Reality QR. And the NuGet site, yeah, we can close that. That's the code difference. I'll just copy it and insert it into the project, so everything is already here. Here you see the scripts. Codes Manager, the codes visualizer, a script on the QR code prefab, spatial graph node tracker, and as you see here, I just added the check for the Unity Windows build, for the UVP build, and everything else I just simplified it a little bit, that not all of this information is displayed, that all the positioning, the data is displayed in a separate text, and the scale. Just dig yourself into the code, it's not that complicated. The manager will just check if the Windows QR should be used here. Again, this is only applied for compatibility reasons for building other platforms like WebGL, Android, and Standalone, which do not support the Microsoft Mixed Reality OpenXR implementations here. The codes visualizer is also the same. Just scroll through it, handling everything. Yes, that looks good. The singleton is just a singleton implementation for Microsoft. The special graph node is for the UWP implementation here, and the graph node tracker will, and we see it here, just use the OpenXR implementation. I removed the dependency for UWP completely, so it will be again a little easier to work with the OpenXR example. If you want to see the whole sample with MRTK, I can add it, but I guess keeping things simple here is a better way to deal with it. There's also result canvas. It's just a wall space canvas with a text, and the text is linked for displaying the result after scanning. So basically that's it. Feel free to check out the code for the Microsoft sample, and I'm going to build here, to do the build here, Microsoft build, waiting for it to finish, and again HoloLens build, open the solution, wait for it, and the settings are here. We are going to deploy it, start without debugging, build is started, deploy is started, video is speed up, and here is the text. And you see barcode is not working, but if I move the QR code into the camera image, we see that the simple cube is tracked here, the barcode, the QR code is red, and the cube will be gradually following the QR code that I printed out. Even if it's moved away, it will still stay persistent within the room, so it's also perfect for, I don't know, placing something in the room like a HoloLens IKEA app or something like this. There are endless possibilities, and it's working pretty good. So that's it for now. That was quite a rush through the whole project. I know there is a lot of code in there, a few optimizations here when it comes to threading and how to design the whole source code stuff and so on, but there is the GitHub repo. Work yourself through the code, try to understand it. It's not that complicated. If you have any questions, feel free to post them as a comment down at the video. Everything when it comes to links, documentation and so on is within the description box, and I would really appreciate it if you like the video, subscribe to my channel, turn on the notification bell, and give me a few suggestions what kind of video you want to see next. So thanks and bye.